like that, where we can see both sides of that story, where we can both see, okay, so in the case of the string systems, for example, there are things that we played with sort of valuations of strings, where you have the string rewrite system, which defines, which has a bunch of axioms that say how to rewrite the strings. And then we also have this idea that strings have a value, numerical value, and then that's a particular model of the strings. But again, it doesn't seem particularly natural.
I don't see why you need the numerical value. I mean, the strings themselves are concrete objects, right? So semigroups, which are basically what you're talking about here, are a good example of something where there is an obvious intersection, right? Strings are a concrete thing. You can do concatenation. You can define algorithmically what the concatenation operation does, etc. And you can also write down the associativity and identity axioms for that semigroup.
No, but. Well, okay, maybe I'm not making my point very well. I mean, the issue here is there is a certain set of things that when you talk about non-constructive proofs, the question is, what is the most simple-minded case? Okay, for example, for string systems, what will be a non-constructive proof in a string system?
Well, but this is my point, right? That if you have a monoid structure, it's quite easy to make it constructive. String concatenation operations are
okay. So what is the So give me the most simple-minded system that would have something non-constructive.
No, so if you had a string system which was augmented, say, by a notion of double negation, so you could effectively do proofs by contradiction in the string system, then you would have a shot at having something non-constructive.
What on earth is so? I mean, I played with ages ago in string systems. Just the string has A's and B's in it, and negation is interchange A and B.
Right. So like you did in it was at chapter 11, the principle of computational equivalence chapter of NKS, right? You had those multi-way systems with zero, with sort of black and white cells or zeros and ones in them, and use them to kind of investigate consistency and completeness by just comparing
right.
Numbers of strings of a particular type. So if you had a system like that, then you could start. Then you can have the situation, and so you have a negation operation. So as well as the concatenation operation, you have a negation operation. Then you can start to make statements like, there does not exist a path between these two strings, which you can prove, which you might be able to prove without actually witnessing that path, right? Because you could take the statement that the path exists and then negate it.
How would I take a statement in that setup? How would I formulate the statement that path exists?
Well, yeah, I mean, you would have to have some way of expressing statements about paths from within the string system itself.
Right.
Which
right there is somewhat non-trivial. I mean, that's a Gödel-like construction.
Yeah, but as soon as you have that situation, and then you can, so if you wrote the statement, there exists a path between these two strings in the string language, and then just negated all the characters, and you found a proof of that in the string system, then you would have found a non-constructive proof that there does not exist a path between the original two strings, because you proved it to be true subject to the axioms of the string system, but you haven't actually witnessed the path.
Right, but this requires that you have some kind of meta. You are able to represent in the string system statements about itself,
right?
Which is already quite non-trivial. That's a non-trivial piece of compilation that we haven't done for string systems,
right?
And which, by the way, for these simple systems, that is like universality proofs, and they're always horribly messy.
Yes,
right.